Divide with variables. Beth has been working to determine the electrical impulse pattern that will work most efficiently to restore lost quadriceps or thigh muscles in a patient with a spinal injury. To complete her research, she must divide the rate at which the muscle regains its strength, 4R, over 5 by the power of the electrical stimuli, which is R squared over 10. So let us simplify this equation. So let's first start by writing it out. So we have 4R over 5. And we're going to divide by R squared over 10. Now, the way we can handle this is by changing this whole equation into multiplication. And the way we would do this is by making this second term and flipping it, or taking its reciprocal, so we can multiply. So we have 4R over 5, and we're going to multiply now, and now it's reciprocal, so we're flipping it, so now the 10's on the top, and R squared is on the bottom. But before we begin to multiply, let's go over a few things again. Exponents are just repeated multiplication. Therefore, you may want to expand the exponents by writing them out. So let's go back to this problem and rewrite it below. So we have 4 times R over 5 times 10 over R times R. So now we can look at all these terms to see if we can divide out any common factors. So we look at the 4R, and we'll look at R times R first. So we notice we have an R here and an R here. So let's cross these out as R over R is equal to 1. Now let's look at the 5 and the 10. We notice that we have a common factor of 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. So let's write this out. So we have 4 times 2 now, as that's all that's left. And then on the bottom, it's 1 times R. So this is equal to 8 over R. So this is our equation now. So let's look at another example. Example 2. Caleb has intense nerve pain due to sciatica. His physical therapist is using electrical stimulation therapy to help block the transmission of the pain nerves and reduce Caleb's overall pain. The amount of time that Caleb can use electrical stimulation therapy without diminishing its effectiveness can be determined by this formula. So we will simplify this formula. So we see that we have 28 RT over 4 divided by 16 T squared R to the third over 10. So we're going to simplify this. And so the way to do this, instead of using division, we're going to actually use multiplication. And the way we can do that again is by taking this reciprocal. So let's go ahead and do that. And we're also going to expand the exponents. So we have 28 R times T over 4 multiplied. So we're going to put the 10 on the top, 16 below, times T times T times R times R times R. So here we go. So before we begin to multiply though, let's start crossing things out that we have using our diagonal rules. So we have an R here and an R here. So we can cross this one out and this one out because R divided by R is 1. Now we have this T here and a T here. Let's cross these out. Now we have a 28 here and 16 here. So we can actually divide by 4 on each one. So 16 divided by 4 is 4. 28 divided by 4 is 7. So now we have this 4 here and this 10 here. So we can divide by 2 with the 4 and the 10. So 4 divided by 2 is 2. 10 divided by 2 is 5. So we are left with, so we have nothing else except for this 7 term in the beginning. So we have 7 times 5. Now we have 2 times 4 times t times r times r. So this gets us to 35 on the top divided by 8tr squared. So this is our solution. So in summary, exponents are just repeated multiplication. Therefore, you may want to expand the exponents by writing them out, and then you can divide out the common variables.